Okay, let's do one last one here. The function in question is 3x squared times parentheses x minus 4, or j of x. I'll just go ahead and copy it on the next page. Okay, well, we can see that j of x is equal to the product of two functions, and f of x times g of x, where, let's see, f of x is going to be equal to 3x squared, which makes f prime of x equal to 6x, and g of x is equal to x minus 4, so g prime of x is going to be equal to 1. And we'll use this information to apply our product rule. So g prime of x will be the first, f of x here for the second, minus the second, times the derivative of the first. And now it's just a plug and chug. I'm going to move down here a little lower. So g prime of x is going to be the first, which is f of x, 3x squared, times the derivative of the second. So that's g prime of x, or just a 1. Oh, sorry, it's not minus, it's plus, isn't it? And then it'll be the second, x minus 4, times the derivative of the first, so f prime of x, which is 6x. Okay, so here's my unsimplified derivative. Let's go ahead and simplify it up a little bit. We get 3x squared plus, 6x times x minus 4. Same thing as 3x squared plus 6x squared minus 24x. So we guess we end up with 9x squared minus 24x. Let's go ahead and see if Desmos backs us up. So I've written our function j of x. I'll put the derivative function in there here to see what happens. G prime of x. Let's make it dotted so we can kind of see what it's doing. Yep. So third degree polynomial becomes second degree polynomial, it seems like. And we think we know what that second degree polynomial is. Let's call it, I don't know, k of x. How's that sound? And we said that it was 9x squared, isn't that right? Minus 24x. And again, turning our function on and off and looking whether or not it overlays the machine derivative given by Desmos. It looks like we have definitely gotten the right derivative. The last thing to consider here would be that maybe some of you noticed something special about this last problem. When you look at this particular polynomial, you could say to yourself, well, why don't you just distribute it and use what we know about taking derivatives of polynomials from the last couple of chapters, I guess from chapter 1 or section 1 and chapter 3. So let's just do that really quick just to see, would we actually get the same answer if we distributed? So in that case, what we get for j of x is we would get 3x to the third minus 12x squared. And what that implies then is that j's derivative would be, well, if I take the derivative with respect to x, I'd get 3 would come out in front, multiplied by 3, so we would get 9x squared. And the 2 would come out in front of the negative 12 and multiply, so we get minus 24, and the exponent on x would come down by 1. So indeed, it works out the same both ways. In other words, the two expressions that I get here and here are exactly the same, whether I choose to use the product rule or multiply out and then use what we know about taking derivatives of polynomials. We're going to get the same conclusion. This is one of the things that people would argue makes math elegant. There are many different ways to get to the same solution. Okay, that's it for now. I'll see you when I get back on Monday. Hope that you're all having a good week.